Hi, this is Austin with Radical STEM Tutoring, and today we're going to solve the integral of sine of the natural log of x. Let's get started. Now, ordinarily, there is no way that we can integrate this with u substitution or anything like that. So what we're going to rely on today is integration by parts. If we know there's a piece that we cannot integrate by any normal means, but there's something else that we can integrate, then we can try to take the derivative of this, and that will lead us to another integral that will hopefully be easier to solve. So if we want to do this by parts, we need a piece to differentiate and a piece to integrate. So let's differentiate sine of the natural log of x, and we'll integrate dx. Now, taking the derivative of this, derivative of sine is cosine, so we get that back with the same stuff inside, and then our chain rule says we also take the integral of the inside, and the derivative of natural log of x is 1 over x times dx. And of course, if you integrate only dx, then you just get back an x. So now, integration by parts tells us that our integral will be equal to, we're going to take these two parts and multiply them together, positive, so we'll have x sine of natural log of x. Then we'll take these two parts and integrate them with a negative sign in front. We have negative the integral of cosine of the natural log of x. Now we have a 1 over x and an x. X divided by x just cancels out to 1, so I'm not even going to write those. dx. So we did something, but it doesn't really look like we're in a better spot than we were before, because now we just have a different trig function housing our natural log of x. So why don't we try this one more time? If we want to integrate cosine of the natural log of x by parts, we need something to differentiate and something to integrate. So again, let's differentiate this big piece, cosine of the natural log of x, and we'll integrate the dx. So derivative of cosine is minus sine of the natural log of x times the derivative of the inside, which is 1 over x, and then a dx at the end. And again, when we integrate dx, we just get back an x. So now our integral will be equal to this x sine of natural log of x is still in front, minus, since we've used by parts on this, everything is going to be inside of these big brackets. We take these two pieces and multiply them with a positive sign, x cosine of the natural log of x. We take these two pieces and integrate them with a negative sign, but since this is negative sine of x, that's going to cancel with the negative in front of our integral to give us positive the integral of sine of natural log of x. The x and the 1 over x will cancel again to just give us dx at the end. And you might notice something here. This is the integral that we started with. This part right here equals I. So it seems like we have just come into a situation where we have two instances of our integral, and in fact that's exactly what happened. So if we can put these two together, like we're just solving for a regular variable in an algebra problem, then we'll have an expression for the value of our integral. So that means our integral equals x times the sine of natural log of x. Go ahead and distribute this negative, minus x cosine of natural log of x, and minus I. Now if we add I to both sides, it'll come from here and we'll get a 2I on this side equals, go ahead and do a little simplification here. I'll factor out the x from both of these terms. And then we just have one more step. Divide by 2. So at the very end, our integral is equal to x over 2 times the sine of natural log of x minus cosine natural log of x. So in the end, we could never actually integrate any of these terms with natural log inside of our trig functions directly, but integrating by parts, we were able to play with the derivatives of sine and cosine and end up with our integral showing up again, which led us to get an expression for what the integral equals. Alright, if you found this video helpful, please be sure to like it and share it, and have a radical day.